We all know sugar is sweet. It's the ingredient that makes desserts irresistible. But sugar isn't always easy to spot. It hides in plain sight, lurking in foods we wouldn't expect. Think about that jar of tomato sauce in your pantry or the yogurt you had for breakfast. Even granola bars, marketed as healthy snacks, can be loaded with the sweet stuff. Sugar has a way of sneaking into our diets, often without us even realizing it. The truth is, sugar is everywhere. Food manufacturers add it to countless products, from bread to salad dressings. Why? Because sugar makes things taste good. It enhances flavors and adds a pleasing texture. And let's not forget the addictive nature of sugar. Food companies know that the more sugar they add, the more we crave their products. But this overabundance of sugar comes at a cost. Our bodies weren't designed to handle the sheer volume of sugar we consume today. This can lead to a whole host of health problems, from weight gain and type 2 diabetes to heart disease and even some cancers. The first step to breaking free from sugar's grip is understanding just how prevalent it is in our food supply. Imagine taking a bite of a delicious cake. What happens next? The sweetness hits your tongue, setting off a chain reaction inside your mouth. Tiny receptors on your taste buds, called taste receptors, come alive. These receptors are like tiny sensors, specifically designed to detect different tastes: sweet, sour, salty, bitter, and umami. When sugar molecules come into contact with these receptors, they send signals racing to the brain. These signals travel at lightning speed, carrying the message that something sweet has been detected. The brain, in turn, interprets these signals as a pleasurable experience, and that, my friends, is how we experience the joy of sweetness. But the story doesn't end there. The signals from the taste receptors don't just travel to the part of the brain responsible for taste perception. They also journey to other areas, including the reward system. This is where things get really interesting, as we'll see in the next section. Deep within our brains lies a complex network of nerves known as the reward system. This system is responsible for making us feel good when we do things that are essential for survival, like eating and drinking. It's our brain's way of ensuring we repeat these behaviors, keeping us alive and thriving. So, where does sugar fit into all of this? Well, when we eat sugary foods, the brain's reward system gets activated. This activation leads to the release of a neurotransmitter called dopamine, often referred to as the feel-good chemical. Dopamine floods the brain, creating a sensation of pleasure. This feeling of pleasure is the brain's way of saying, "Yes, do that again." And here's the catch: the more sugar we consume, the more we crave it. This is because the brain becomes accustomed to the dopamine rush associated with sugar. Over time, we need more and more sugar to achieve the same level of pleasure. Section 4. Chasing the sugar high tolerance and the cycle of cravings. Remember that initial rush of pleasure you felt the first time you tasted sugar? It was almost magical. Sadly, that feeling doesn't last forever, and it fades over time. As we continue to consume sugar, our brains start to adapt in response. This adaptation leads to a phenomenon called tolerance, which is quite common. Tolerance means that we need to consume more and more sugar to achieve the same level of reward or pleasure. The dopamine rush we once experienced from a small piece of candy now requires a much larger amount to feel the same. This can lead to a vicious cycle of craving and overconsumption, which is hard to break. We chase the initial sugar high only to find that we need more and more to satisfy our cravings, leading to frustration. This cycle of tolerance and craving is eerily similar to what we see with addiction to substances. While sugar may not be as addictive as some drugs, the underlying mechanisms in the brain share striking similarities, making it a concern.